Okay, YouTubers. Been working on the loop again. Found out a few things, and I wanted to share it with you guys. Because it almost brought the project to a screeching halt, and come to find out it was my own stupidity, of course. Isn't that always the way? But yeah, I beefed up the figure-of-8 loop now. So it's double looped, and it actually brought in the bandwidth for the higher end of the bands. And I made it match. I couldn't resist. But I wanted to show you a few things, guys. Oh, did you get your FT8 in dark mode yet? Dark mode, FT8, guys. Okay, now I've been using this for FT8, guys, because I'm only a tech. I can't transmit up on 40 above 10, so I've been FT8ing with it on 10. So I got the little loop, the figure-of-8 loop there, tuned in for 10 meters right now, and man, does it work. Woo! Let me show you. It's kind of weird. I can't get local contacts with it. I can talk far away, Brazil. I got Brazil, and man, I'm just peppering the West Coast. And I got a contact in Australia yesterday when I finished it, but it didn't log it. I don't know why. Maybe we didn't get a 73 or something. But yeah, DX with it is awesome. But I tried local around my state, and yeah, it's not working out too well. So I think I figured out why. By adding a figure-of-8 in there, it changed the velocity factor of the antenna. So basically, when it was on the single loop, I could transmit local, and it was okay. As soon as I put the figure-of-8 loop in it inside, it's DX. I mean, for some reason, I'm bouncing over local. I'm not even. They say the two guys I've talked to said I'm just faint, and they can't believe it. They're like, "What in the world?" And that's on 10 meters. So there's a few things I learned. As you can see, I had to beef this up, and this is not. This is fiberglass, guys. I had to cut a fiberglass pole in half, split it. You can see the split, okay, from one mount where the screw goes in to where the other screw goes in. Because when you transmit off 100 watts, guys, and you're pumping that much wattage, that's what happens. She melts. When you're putting that much voltage through, you can't attach it directly to PVC. I found that out. So there was a short. That shorted right there. Okay, that cost me half a day. All right, now we'll throw that aside. Okay, here is a whole day. Okay, now here's the key. Let me set this up here so you guys can actually get without shaking here. This, my friends, is cheap ass Amazon Coax. Okay, it's marked, but that's it. There's no stamping on it. There's no nothing other than manufacturer stamping. And I'll show you here what it looks like. So let me cut this open for you, and you will see the difference. I've got two kinds. Something happened. Let me show you what happened first. Okay, I run the coax through the pipe on the loop, and this happened. That's a short, guys. And I was watching the standing wave meter, and the standing wave would stay steady at 1.3, and then it would just keep climbing and climbing. The more I put wattage to it for FT8, it really started to climb, and then finally she popped. And that's what you get, guys. You get shorts, you get arcs on a Magloop when you pump high wattage to it or higher wattage to it. You create basically, if you're throwing 100 watts into that antenna, you're probably generating 20, anywhere from 10 to 20,000 volts out there on that antenna. Okay, that's a lot. All right. Now, this was one day. Okay, got it all finished, and I was testing it, putting wattage to it, and testing it on FT8, and then that happened. Okay, dead short right there. Okay, so that was a whole day. So that was a day and a half counting the PVC incident. So I figured out it was the Coax. All right, checked the capacitor. There was no arcs on the fins. So I thought, well, I got lucky. So I redid it. Okay, put new Coax in it, and then that happened. All right, there's another short. Now take a look, guys. This was within about an inch or two there of gap, and that happening two times in a row in the same spot is not cool. Okay, now I'll explain this later. I'll take you over the toroids I had on there. If you can see inside there, I don't know if you can see inside there, there's a short. All right, that was a quick learning lesson. It shorted out across that toroid. There's a lot of voltage going through there, so it ruined the toroid. Okay, that one too, gone, shorted. Okay, two shorted coaxes in pretty close proximity of each other. So I got to thinking, and I couldn't figure it out. It took me 2 days to figure it out. Okay, and I was stuck. And here's what it was, guys. So simple. My own stupidity. You see where that capacitor's mounted, right? Okay. I had the coax coming up from the bottom there. Now let me show you that. I had the chokes down here, because that's for later. There's going to be a lot of voltage action going on here later, so we want to protect that. But I had one coax running this way up this pipe, okay, up the center pipe, and connecting the big loop out here, okay, right there. I popped it out the center pipe right there. So I thought, well, I'll just run this one directly up, straight up, right? And then pop out and connect to it from here, right? Okay. Good idea, right? Well, my absent thinking, and it literally took me 2 days to figure this out, because I couldn't figure out where this short was coming from. I knew that it was not coming from, because the length of that coming off there, it was down in this area right in here. I knew it wasn't coming through that PVC pipe and through this fiberglass to arc. Guess where it was arcing? The screws I run into the pipe, right, were about that far into that pipe. And guess what I was doing? Running the coax directly up that pipe and right past that screw, those two screws. And I was feeding it out here. And when you're throwing that much wattage and that coax is sitting that far away from that voltage coming directly off that capacitor, it was blam. It was shorting out every time right there on that screw. See that you can even see the screw indentions in it. And right there you can see this, it really shorted, it blew out. This is the cheaper coax right here. Alright, and so you can see what happened. my own stupidity, I didn't think about that. Whenever I did it, I thought, well, that'd be just perfect. That'd be fine, you know. See, that's kind of stuff you got to watch out for, guys, when you're building. You can have one stupid mistake like that, and it just ruins it the whole lot. So that was a mistake. That cost me 2 days of trying to figure out. So what I did, I figured out from this fiasco right here that this is going to be a problem. Right here, I can see we're going to have heat problems coming through the PVC, okay, on this. So I'm going to have to redesign this. For as much heat that was coming off this capacitor right here, there's going to be a lot of transfer right here. So I'm going to have to, I've already got an idea. I'm not going to share it with you guys yet, but I'll show you when I'm done. And but what I wanted to show you was the little loop. Because you're making a figure eight, you really got to insulate the connector points, especially, you know, right here, okay, where they're almost touching. But no shorts, no nothing out of that. That was fine. I had I just took a PEX pipe and drilled holes in it so I can get my spacing nice and tight, nice and solid, right? And I attached it down here at the bottom. Okay. Comes up into a figure eight. Now you could swap it over if you wanted to, the figure of eight, put it on that side or whatever. It doesn't matter. As long as you get one, you know, make your 8 connection and you're going through your capacitor. So, but here's the top connection. So what I did, guys, to fix that problem, I run both the coaxes, as you can see, out the center. Right here. So I just went through the center. There's nothing through the center pipe except for way down here. So I come in and come across right here, okay, and then up. So I came in, over, and then up. And then fed the little one through this side and the bigger one through this side, like it always was. And this is how I did the loop on the top. So this is your little loop, and I just stuck it in between there. Put it kind of closer to the main feed wire, the longer one. And as like I say, the longer one, let me explain. This one where it comes in together right here, and then I soldered it right here together. This outside one's longer. It goes all the way down. So this is just tricking the antenna and making it think it's thicker material, and it gives you a wider bandwidth on the scope. Okay. So we're tricking it. This one works 10 all the way. Well, actually, it works on 50 megahertz. I can actually tune a standing wave on it, 1.4 on 50 megahertz with this 6 meter. So it'll go 6 meter all the way up to, well, if I put this capacitor out, if I put this capacitor in line, okay, so it's a true 100 puff, with that capacitor in line, I can go all the way down to 17. And if I take the capacitor out, I can go down to 21 megahertz. So that's only adding 50 puff in there. But here's a rule, guys, when you're building Magloops. As you know, I had this as I tried this as a single loop, okay, to test with, to make sure each one was a single loop. The more metal you add to an antenna, or the more metal you add to your loops, the more capacitance you got to add. So I'm right on the verge of running out of capacitance right there with that 100 puff. So I'm going to try getting another one. But man, those capacitors are going up. I bought that one for $35. And right now, the price on them are $90. So everything's going up. I got that one, I think, I can't remember, $50, $60 or something. But that one's huge. But yeah, that's a shame. So it still works, but it comes right to the edge of 24 megahertz, and it kind of just, yeah. So what I'm gonna do, all right, is leave it alone because it works great. And I've been FT8ing with it on 10, and it still receives wonderful. Transmit, I think, though, the velocity factor's changed on it. It's like I said, it's difficult for me to get local. That's weird. And even the guys I've talked to are like confused about that. But I think what's happening is that velocity factor's changed, and I'm just overshooting them, basically. So it's a great DX antenna, and that's what you want for FT8 is DX. And because we can switch to the bigger loop and the smaller loop, we can cut out the noise. So it's a double banger there. You're getting noise floor cut out, plus you're getting distance with it. So it's strictly going to be FT8. I can probably talk DX on upper sideband with it on 10 meter, but I haven't done that yet. So I've just been testing. I got it all done now. I tested it yesterday, and for about, I don't know, 30 minutes or so, it was really rolling in on 10, and I gathered up all those guys and then that guy down there, and that was about 10 minutes worth. But yeah, that's not too bad for 10 meter. There, I guess I can show you guys. 10 meter. Work 12. 12 confirmed. Or 12 and confirm 0. I don't know how to confirm on this. I don't know what's going on. So I'm going to have to work on that deal there. But as you can see, it works really good for FT8. I mean, it works awesome for FT8. And I had it outside. I got it outside now, guys. I got a mount outside for it. And I'm going to do a video FT8ing with it outside, so you can see it actually working and doing its thing. I can show you now, I guess. Let me kick this over to 40. And we'll rock it in. There you go. You can see it's streaming in on 40. It's always working on 40. I'm not tuned for 40. It's just a little off. You can see it over there, but it still works fine. You can see how much bandwidth it's got. That's off the big one. Matter of fact, I think I'm on the little Coax. Nope, that's the little Coax. You can see the noise floor just drop out. It's awesome. You can still hear the FT8 working. But yeah, guys, that's what it's supposed to look like all the time. But 10 meters, of course, your propagation kind of falls in there. But yeah, that's working off the big loop. So that's a good little worker. I'll show you whenever I do the test run. When I got it outside, how all you got to do is get that capacitor close, set it outside, and then you can use the big one to tune the standing wave. Using if you're just using the little one, you can use the big capacitor and tune it off the box right there. And all I do is I get the little capacitor close, right, just within range of it, and then whenever it comes time for me to lock it in on a frequency, I just tune the radio to the frequency, reach over and hit the switch to rotate the big capacitor, and then I just watch the standing wave meter drop until it gets to its lowest point, and then I shut that off. And then it's tuned. And I'm going to work on a different tuning method too. I found out I can use using the VNA, the Nano. I think I can make a tuner box for this. So I'm going to try that. But that's later on. So, alright, we figured out our shorting problems. We figured out we got a lot of heat going on right here. When you're transmitting, that's a lot of heat. A lot of stuff going on there. Alright, so I'm going to run into a lot of problems down here. This is going to get hot and melt pipe, I think. So where I'm gonna have to redo some of that there. But I got an idea for that. I'll save it for a video. And of course, let me step you through this cheap coax. I want you guys to see this because this is very interesting to me. I just wanted to show you guys this. This here is the American-made stuff I bought, and my own stupidity I shorted it. But you can see that copper. Okay, that is copper. Pure copper. And we'll pop this off. That's pure copper right there. So you guys can see that. That is awesome wire. It's American made. I got it on Amazon actually. And but I went with an American manufacturer, not Chinese. This is Chinese from Amazon. I bought it because I was just using it as receive. But this is why you don't want to buy cheap ass coax, guys. That's not copper. They say it's tin coated copper, but it won't solder. You cannot solder that. I've tried. So it's not copper. Center one is. Right? Center one's copper, but that braid is not. That's cheap, guys. You can't even solder. I've tried soldering it. I just give up. I started using crimp on connectors. That's what I had to. So that's the difference between that cheap coax there from Amazon. It's just barely marked, no manufacturer's date, nothing. But this is the good stuff. That's pure copper all the way through. That's RG8X, and so is this. They made this one's thicker for some reason, but it's cheaper. That's for sure. You can definitely see the difference in it. So that's why you don't want to buy cheap coax, or you need to check your coax. You get new coax in, you know, that's what you need to look for. Okay, that's cheap. This is not. Okay, and enough of that. That's good for you guys. Now you learned something there too. All right. Now, one more thing I was going to show you. Had to figure out the heat problem here, so I've mounted the fiberglass to it. Show you guys the gap there. I didn't want to connect it to one piece. Let's put one over here, there on its own, and one over here on its own. And then, of course, I screwed it through into this. And then don't run your coax through the same pipe. Always check the back of your screws. Always check that. That's a learning lesson, guys. There I learned. So, we're gonna fix this. We're gonna have issues there with that antenna coming through the PVC. So I'm gonna fix those issues, and maybe beef up this connection here. So, but I left this. You guys know this is the hot side, because our center conductors come off to here on this side. Okay, center conductor on this side. So we're creating that magnetic field or flow this way. It makes this antenna directional. It somehow, I don't believe me. I know they're somewhat directional for noise and stuff. You got your null right here, right? Okay, but somehow, if I turn this antenna, and I marked it with a red one there on the hot side, and then I put the red in there for the hot side. So if I turn the antenna to where this is pointed east, I will get more easterly contacts. Okay, and if I turn it west, I'll get more westerly contacts. And then if I did this on FT8 just to track it. I started up northeast by Canada, and then I just went out there and kept rotating it towards the west like this. And as I did, it changed the location on that grid map where I was picking up contacts. So it is directional. So, but what's cool is I can still get transmit and get contacts off the backside of it. That's where I got the Brazil contact down here. Well, I'm on 40 now, but that's where I got that Brazil contact, was off the back side of this right here. Off this side, it was facing that towards Brazil, and it came in. So there is some rejection and going on there, and I don't know. This definitely has something going on with the velocity factor. To be honest, guys, I'm just not able to figure that out. It's above me, but I know it likes DX. This thing really loves DX, so I wanted to share that with you. Now I'm going to do another video of it outside. We'll start that video. We'll have everything up and running, and then I'll poke you out the window so we can take a look at how it's mounted. It's just temporary, and I wanted to show you the chokes. I took the chokes away from the Coax up here. They shorted. Okay, this one got way too hot and shorted inside. Okay, I don't know if you can see it or not, but yeah. But yeah, I had to remove the chokes from there. Okay, so what I did was I realized this is going to get hot down here, and so we moved all our chokes to here, so we're just covered here. So that should knock out a future problem, hopefully. Knock on wood there. So other than that, I got new Coax in. It's all black because I was shorting stuff out here. I didn't want to trust none of that. All right, so I got new Coax. We're all tied in with new Coax now, and I tested it yesterday, running it at 100 watts. Standing wave never moved, and so we should be good to go. It didn't get too hot, kept the heat in, so no shorts yeah, as of yet. And now I haven't tried transmitting off the big one yet. Okay, it does transmit, no problem. It's got a low standing wave, but I've been transmitting off the figure of 8 on 10, doing FT8 over there, and I'm enjoying that. I didn't think I would, but it's kind of like hunting or like fishing. You know, you throw your bobber in the pond there, and then you hope you catch one of them. And it's kind of fun. After a while there, I got kind of addicted to it a little bit, and I wanted to get more, you know, so that kind of fired me up to get it outside. You know, man, when I got it outside, boy, it really works. A lot better than inside here, that's for sure. So, but I wanted you guys to see this because I like it. I doubled up the figure of 8 and make it match. So, other than that, we're close to getting it weatherproofed. I've been testing outside, make sure we're not going to have any problems before I go spending the money for the boxes and stuff. So, okay, other than that, we're going to leave it at that. You learn about cheap coax. We learn about our connections and leave our Magloop stuff there tight. So, no excess stuff, no resistance. So, other than that, there you go, guys. I'm gonna call it here, and in the next video I do, we'll be outside, okay? And it'll be sitting outside, and then we'll come in and do some FT8 and with it, we're showing how it works, transmitting, and then we'll get that going. But other than that, guys, have a good one. 73s to y'all, and make sure you hit the like button, please, because it helps me, helps my videos get seen, and I think it's good content. So hit the like button and subscribe. Don't forget to subscribe. But anyway, thank you guys. Y'all have a good one, and I'll see you on the next one.